Okay, excuse me. So we are solving exponential equations and inequalities using tables and graphs. Okay? I showed you how to solve this equation, this particular example, algebraically, so that we know what the answer is. We know what to look for when we're looking on our graph and our table. Okay? So this is how we're going to do it. We're going to go home, not actually, but on your calculator, go home. And we're going to create a new document. Okay? No, we don't want to save our old one. We want a clean, fresh graph. Whoa. Clean, fresh graph. Okay? So here's how we're going to enter it into our calculator to solve it graphically. Alright? I want to take one side of my equation, in this case the left side, and I want to put that in F1. So I want to enter, excuse me, 3 raised to the 2x, whoa, minus 4. And I hit enter. Now remember, I only put one side of the equation in there. What do I do with the other side of the equation? Yeah, I put it in F2. Okay, I hit tab to get the F2 to come up, and then I'm going to enter the other side of the equation. 3 squared. Now, this crazy kid earlier said, what about, can I just put 9? What did I say? Yes. Because what is 3 squared? 9. Okay. I don't know, maybe his finger was hurting from pushing buttons. I don't know.
Maybe make your line darker.
How do I make my line darker? I don't know.
Oh, now it is. Oh, you're thinking of
Okay. So, I've put both of my equations in here now. Does it look like the graph that was given to us?
Yes. No.
It doesn't, does it?
Farther out.
It has a curvy part and a straight part. This only has a curvy part. So did I break it? No, I just can't see everything, can I? It gives us a window. I don't want to look at that yet. Because what happens if I'm not given a window to use? How am I going to figure out what I should change my window to see everything? Well, one of my y values is 9, isn't it? This only goes up to 6 2/3. So if I go to menu and window and to edit my window settings, I know my y max has to be at least 10 for me to see it. That looks better, doesn't it? Still not exactly the same. If we're doing this by ourselves, that's perfectly fine. Okay? But since we are following this example, let's go ahead and change our window to the one they give us. Menu, window, window settings. Now, this doesn't look like window settings that they normally give us. They normally say x min equals blah, blah, blah. X max equals blah, blah, blah. Is this telling us enough information? Yeah, we just have to know how to interpret it, don't we? The x's have to be from -1 to +5. So my minimum needs to be what? -1. My maximum needs to be what? 5. How do I need to count? What's my scale? 0.5. Okay, it's right there, yeah. What's my y minimum? Well, my y's need to go from -1 to 10. So my y minimum is 1. My y maximum is 10. How do I need to count on my y's? By 1. Now, does that look better? It does, doesn't it? Okay? So if I have two things that are equal to each other, like I do in the problem right here, where do I find the solution? Wouldn't I find the solution where their graphs are equal to each other? What's that called?
Middle.
Close. It's called their point of intersection. Right? So in this particular graph, it's going to be right there. And on our paper, it's going to be right there, right? So we can actually use our calculator to help. Since we are using our calculator, solve using tables and graphs, let's use our calculator. Menu, analyze graph, intersection. It'll actually find it for us, right? Now the first thing it wants is the lower bound. That means it needs to be on the left-hand side of whatever we're trying to find. And the point of intersection is right there, so is that dotted line now on the left-hand side of that intersection? Yeah, so I click the middle button. Now it says upper bound. Where do I need to move it? To the right-hand side. Okay? So I slide it over to the right-hand side. Now, did you notice what showed up when you slid it over to the right-hand side? Did you see that dot appear? It wasn't there before, was it? When I click the middle button, it darkens the dot and it gives me the intersection. It gives it to me earlier before I hit the middle button. It's real light. But once you hit the middle button to say, yes, this is my upper bound, it gets dark and you can see the solution is 3, 9. Okay? Now, we kind of already knew that, didn't we? When we solved it algebraically, we got an answer of x equals 3. So where does the solution show up in the point? Does it make sense it's the x coordinate of the point? Because what is the only variable in my original problem? X, isn't it? We added another variable in when we chose to solve it with graphing. We added the y in, didn't we? Okay? Look real quick at the table. Control T. The table's going to be nice sometimes. Okay? The table's going to be nice sometimes. Sometimes it's not, and you're going to tell me in a minute when it's not going to be nice. Okay? But I know right now I got X and F1 and F2. Those are the two that I used, right? And I know my solution's at 3, 9, so I want to know 2, 3, and 4. Okay? I want to see my intersection, and I want to see a point on either side of it. So when X is 2, Y is 1 and 9. When X is 3, Y is 9 and 9. And when X is 4, Y is 81 and 9. Okay? We've done this before. It's been a while. So I need to make sure you remember what we're looking for when we look for the solution on the table. Can you tell that it's right there? Because these Y values are the same. When the Y values are the same, once again, the solution is the X, because that's really the only variable that was in our problem to begin with. It's only one variable, just the X. Okay? Does that make sense? Okay. So, you're going to do 7, 8, and 9. And I need to make this clear because I don't want you to think it's some sort of secret or that I'm some sort of idiot that doesn't notice things. Because sometimes I am, but not today. Okay? Look at number 9 and number 6. Same thing. Okay? So am I just being evil by giving you the problem twice? No. I wanted it to be kind of like this one up here where you already knew the answer because you've already solved it here on number 6. Now it gives you kind of a general idea where to look in the table and on the graph. Okay? Look at number 8 and compare number 8 to number 2. It's the same, right? Look at number 7 and compare number 7 to number 4. All right? So that's on purpose. That wasn't just an accident. Okay? You've already solved it algebraically. Now solve it using a table and a graph. That'll help you see, I think, the similarities in the two. Fair enough? Okay. The last thing I need to show you today. Oh yeah, go ahead and circle 7, 8, and 9 if you haven't already, because you're going to be solving those as well. Thank you. Let's talk real quick about example number 5. Okay. On example number 5, we are, I solved it for you algebraically, or I will very quickly. We already have like bases, so we can say 2x minus 4 is less than 2. Right? That's how we solve that? You can erase that if you want. So I would add 4 to both sides and get 2x is less than 6. Not 8, right? Not 8. And then divide both sides by 2 to get x is less than 3. Now, anytime in the past, when we did linear functions, when we did quadratic functions, things like that, what was the difference between solving the equation and solving the inequality? Up until the very end, you solved it the same way. In inequalities, you had to shade. Okay? So this time we're not going to be shading on a graph like this. We're going to be shading on a number line. And I've got a 0 and I've got a 3. Okay? 3 because that's what I got from my inequality, right, from when I answered this inequality right here. And a 0 just to give me peace of mind that I'm doing the right thing. Okay? X is less than 3 looks like I should shade to the left. Okay? The 0 gives me a check for that. If I put in a 0 up at the original equation, what's 2 times 0? 0 minus 4, negative 4. So what's 3 to the negative 4 power? We can even let our calculator do that for us, right? 3 raised to the negative 4 power. 1 over 81. Now some of you saw that because you knew that 3 to the 4th power was 81, but it's a negative, so you knew you were going to try to make it happy and move it to the denominator, right? So is 1 over 81 less than 9? Is 1 over 81 less than 9? Yes. So for sure, from the 3, I need to shade toward the 0. But that's what I already knew anyway, right? So this is kind of a check. Okay, using the 0 is kind of a check. So on the 3, of course, we have an open circle, and we shade to the left. Why did I say, of course, we have an open circle? I need you to remember that. I don't want you to feel dumb for not remembering. Because it's not equal to, right? It's just less than. Because it's just less than, we need to make sure to have an open circle on 3. If it was less than or equal to, we would have a closed circle, right? But we shade to the left. And this is our answer. This stuff right here is our answer. Any questions about that? Okay, so make sure you circle number 10. You're also going to do number 10. So we're clear. 4, 5, and 6, 7, 8, 9, and 10. Okay? Please look back at our goal for today. What was our goal for today?
Please do one.
It says, I will know I have it when I can solve an exponential equation or inequality. Do you feel like you reached your goal today? Do you feel like you can solve one of these things? Good. Do it. Okay? Do them. You have the rest of the period to work. All period. Okay? Use the calculator if you need to. Okay? Peace.